For our robot design, we used a structured approach to make the robot. We studied our mission priority and adapted the robot to complete the missions. Our robot is a basic EV3 educator build, however we modified it specifically for the missions. We added large wheels for speed and height. We added gyro and color sensors to help with repeatability, and added a wheel guard to help with alignment and to protect the wheels from possible interference. We also added several attachments to complete missions efficiently. So on the left we have our bumper, and on the right we have the wheel guard.
Okay, so these are the attachments. So on the one on the left is for the bench. We pretty much had this thing where we push down the bench and we drop all the cubes in, and then we have another thing that pushes the arch into the square thing, and then on the next one we have a dumper to dump all the blocks in the bocce over there. The third one is pretty much the thing that helps us do the step counter thing. It pushes the wheel. Next page. And then this next one is supposed to catch all the slide people, and then second one is supposed to push all the people outside, and the third one is the treadmill.
Our mission strategy. How did we select what missions to complete? We used a mission matrix to evaluate the missions for their difficulty and amount of points. We multiplied these together and used the priority ranking. We then brainstormed which missions could be done in the same runs and started programming. This is our ranking matrix and mission board.
This is our mission board. The arrows show where our robot goes for each mission and how we paired missions together. Next slide. We selected our run order by the following rules. We had to minimize attachment changes. Dance had to be last, and Bashi is in 2 parts due to its location. Next slide.
This was our programming strategy. We used the gyro for turning and driving straight. We used my blocks to simplify coding, port view to determine angles and lengths instead of guess and check, and we used mission models and walls to locate the robot while it's on the board. We used attachments to simplify coding and robot tasks. Here are some examples. The top example is a gyro drive my block. This code uses inputs of power and distance as inputs to drive straight with the gyro. Credit to Builder Dude. Gyro turn my block. The bottom one is a gyro turn my block. It uses input of angle to turn with the gyro. Credit to Houston.
This is a coding example for our slide code. You can see some of our my blocks and split blocks being used. Next slide. How do we test and improve programming? We made rough code and then refined it on the board. We added my blocks and more sensor usage to add repeatability. Combined missions into runs for speed, and attachments. Started with the attachment ideas, then refined after trial on the board. Also look for additional ideas from other teams on YouTube.
What is innovative about our robot game? We feel our attachments for the slide and bench missions are innovative. They allow us to get maximum points quickly and repeatedly. Next slide. The end. Thank you for your time.